In this video, we're going to review finding trig ratios given one solved trig ratio. So for example, in the first one we have is if sine of b equals 3/7, find the 5 missing trig ratios. So before we start answering the question, let's just put over here what are those trig ratios, right? So we start with a right triangle. This is my angle. I'm just going to call it theta. And I have opposite, which is opposite of the angle. I have adjacent, which is right by the angle. And I have the hypotenuse, which is the longest side, right? Or the other side. We have that sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. These three trig formulas have their reciprocals, right? So the reciprocal of sine is cosecant. So cosecant of theta, it's going to be hypotenuse over opposite. Secant of theta is going to be hypotenuse over adjacent. And cotangent of theta is going to be adjacent over hypotenuse. If you see the reciprocals, or for the reciprocals, we have pairs of functions, right? So sine is going to go with cosecant, and you see that the reciprocal means that their numbers are switched, right? So cosine, I have exactly the same thing. Cosine and secant are reciprocal functions. And the last one is tangent and cotangent. And you can see that the meaning, the sides are just switched around. All right. So in this case, when we're doing this type of exercises, we only have to find two functions because one is already given, and the other three, we can just get them by switching the numbers around, right? Because they are reciprocals. So let's get started with the actual problem. So they're saying sine of beta equals 3/7. So I'm just going to put my triangle over here. This is the right angle. This is beta because that's the name of the angle. And 3/7, sine of beta equals 3/7 means that 3 is the opposite and 7 is my hypotenuse. So 7, 3, and the adjacent is the side that I do not know. But if we have a right triangle, that means that I can do Pythagoras, right? So I have adjacent square plus opposite square equals hypotenuse square. In this case, adjacent, I do not know. The opposite is 3 square, and the hypotenuse is 7 square. So I solve for A, right? So A equals 7 square minus 3 square, square root of this. So that means that I have 49 minus 9 square root. I have A equals square root of 40. Square root of 40 doesn't have an exact square root, but I can simplify it because 40 is the product of 4 and 10. And I can get the square root of 4 is 2. And square root of 10, we will just leave it like this, right? Okay, so that means that I have my triangle labeled. So if I have my triangle labeled, that means that I can find my trig ratio. So this is 2 square root of 10. So I already have sine. So let's find cosecant. So cosecant is the reciprocal. So it's h over o. So it's 7/3. Then I have cosine. Cosine is adjacent over hypotenuse. Adjacent is 2 square root of 10. And the hypotenuse is 7. And the reciprocal of cosine is going to be secant. So secant is going to be 7/2 square root of 10. The other one is tangent. So tangent is and I switch the angles. Tangent is going to be opposite over adjacent. So opposite is 3 over 2 square root of 10, and cotangent of beta is going to be 2 square root of 10 over 3. So those are my answers, right? One thing before we move on, when we have square roots at the bottom, we usually like them on the top. I have on this one, and on this one, I have this square roots at the bottom, right? What we can do is something called rationalizing. So we multiply by the square root on top and bottom, and we're not changing anything since square root of 10 over square root of 10 is 1. And we just simplify, if you want to see that way. So we have 7 square root of 10 over 20. And here we have 3. So I have tangent of beta, which was 3, 2 square root of 10. If I rationalize, I multiply the square root on top and bottom, and I have 3 square root of 10 over 2 times 10, which is 3 square root of 10 over 20. And that's how we usually express this trig ratios, right? Okay, so let's do another one with cosine. The process is going to be the same. We first need a labeled triangle, and for that labeled triangle, we use Pythagoras. So in this case, we have theta. Cosine is going to be adjacent over hypotenuse. So this means that adjacent is 3 and hypotenuse is 5. Adjacent is 3 and hypotenuse is 5. So we need to find out how much the opposite measures, right? Before we move on, let me just write the trig ratios over here. I have sine. Sine is opposite over hypotenuse, so I have cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The reciprocals, the reciprocals are cosecant, this is secant, and this is cotangent, right? Okay, so the first thing that I'm going to do is solve for the triangle. I have hypotenuse square equals adjacent square plus opposite square. I need to find the opposite, and I have hypotenuse square minus adjacent square equals opposite squared. So opposite is going to be the square root of hypotenuse square minus adjacent square. So hypotenuse is 5 squared minus 3 squared square root. I have 25 minus 9. This is square root of 16. So this is 4. So my opposite is 4. If I solve this, no, I already did. So now the only thing that I need is to set up my trig ratios. So I know that the reciprocal of cosine is secant. So secant of theta is going to be 5 over 3. Then I go sine of theta is going to be opposite over hypotenuse. Opposite is 4, hypotenuse is 5. The reciprocal is cosecant, so it's going to be 5 over 4. Then we have tangent, which is opposite over adjacent. Opposite is 4, adjacent is 3. And then we have cotangent, which is the reciprocal. So I have 3 over 4. If you see, the process is the same. What we want to do first is to have our triangle labeled. After that is only putting the trig ratios together. The last example that we will do, just so we have an example of each, is going to be tangent. So again, I start with my triangle. It's a right triangle. this angle is named alpha, and I have 8 over 15. So if I have 8 over 15, tangent is going to be opposite over adjacent. So I have 8 over 15. This is 8, this is 15. So the hypotenuse is the one that I do not know, right? So let me just write the ratios over here. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And the reciprocals are cosecant, secant, and cotangent. These are the reciprocals. Okay, so if I do my triangle, I have hypotenuse square equals adjacent square plus opposite squared. So here I have 15 squared plus 8 squared square root. So I have 15 squared plus 8 squared, I get 289. And the square root of 289 is going to be 17. So my hypotenuse is 17. So now I have my triangle labeled. So now I just need to get the trig functions. Tangent, the reciprocal is cotangent. So I just switch the numbers around, 15 over 8. Then I go sine of alpha Sine of alpha is opposite over hypotenuse, so I have 8 over 17. The reciprocal is cosecant, so I just switch them around, 17 over 8. Then the last one is cosine, which is adjacent over hypotenuse. And the reciprocal, which is secant, which is 17 over 15. So again, the process is the same. The first thing that you want to do is to label your triangle and see what side you are missing. The next step would be to use Pythagoras to completely label your triangle. And the last step is put together your trig ratios. Remember the definitions of the trig ratios and also the reciprocal of each function.